Space exploration is not just about rockets and astronauts, it's about pushing the boundaries of science and technology. One exciting frontier is the manufacturing of materials in space, an endeavor that's poised to revolutionize industries on Earth. Imagine a world with stronger, lighter materials, or with flawless optical components for telescopes and electronics. This is the promise of space manufacturing. On Earth, gravity often limits what we can achieve. It causes imperfections in materials and makes it difficult to create certain substances in their purest form. However, in the microgravity environment of space, these limitations disappear. This unique environment allows scientists to manipulate materials at a fundamental level, creating substances with properties not found on Earth. This new frontier of manufacturing isn't just a scientific curiosity, it's a necessity. As we demand more from our technology, we need materials that can keep up. Space manufacturing offers a way to meet these demands, paving the way for a future where technology is limited only by our imagination. The quest to manufacture in space is not just about overcoming technical challenges. It's about unlocking the full potential of materials science. Among the many materials being explored for space manufacturing, glass stands out as particularly promising. Glass is an essential material in many industries, from construction and telecommunications to medicine and aerospace. However, the quality of glass, especially for high-performance applications, is limited by Earth's gravity. In space, scientists can create glass that is purer, more uniform, and has better optical properties than anything possible on Earth. This is because the molten glass, free from the pull of gravity, can cool and solidify much more evenly. This results in glass with fewer defects, higher transparency, and improved refractive index, making it ideal for use in advanced optics and electronics. To understand how this works, imagine trying to build a house of cards in a windstorm. Gravity, like the wind, can disrupt delicate processes. In the stillness of space, the house of cards of glass molecules can be assembled with far greater precision. This level of control opens up exciting possibilities for tailoring the properties of glass for specific applications. The exceptional clarity and quality of space-made glass have significant implications for astronomy and our understanding of the universe. Telescopes, the eyes with which we observe the cosmos, rely heavily on high-performance glass for their lenses and mirrors. By using space-made glass, we can build telescopes that are more powerful and sensitive than ever before. These advanced telescopes could capture light from the most distant corners of the universe, revealing previously hidden details about the formation of stars and galaxies. They could also aid in the search for exoplanets, planets orbiting other stars, and even help us detect faint signals that could point to the existence of extraterrestrial life. The quest to understand our place in the cosmos is intimately tied to our ability to observe it. Space-made glass promises to revolutionize this quest, offering us a clearer and more profound view of the universe than we could have imagined. It's a testament to the power of human ingenuity that we can now reach for the stars, not just to explore them, but also to harness their unique environment to advance our understanding of the universe and our place within it. The secret to the remarkable properties of space-made glass lies in its unique atomic structure. On Earth, gravity pulls atoms towards the center of the molten glass as it cools, leading to variations in density and structure. This uneven distribution of atoms can scatter light and cause imperfections, limiting the glass's transparency and optical performance. However, in the microgravity of space, atoms are free to arrange themselves in a more uniform and ordered manner. This results in glass with a highly homogeneous structure, meaning its properties are consistent throughout. This uniformity is what gives space-made glass its exceptional clarity, strength, and resistance to extreme temperatures. To unlock the secrets of this atomic dance, scientists use advanced tools like neutron diffraction and X-rays. These techniques allow them to study the arrangement of atoms within the glass and understand how the microgravity environment influences its formation. The insights gained from these studies are not only crucial for optimizing the production of space-made glass, but also for advancing our understanding of materials science as a whole. The potential applications of space-made glass extend far beyond astronomy. Its exceptional properties make it highly desirable in a wide range of industries, promising to revolutionize technologies and improve our daily lives. In telecommunications, space-made glass could be used to create ultra-pure fiber optic cables capable of transmitting data at unprecedented speeds. This would have a profound impact on internet connectivity, enabling faster downloads, smoother streaming, and more reliable communication networks. In medicine, the biocompatibility and durability of space-made glass make it an ideal material for use in implantable devices, such as pacemakers and artificial joints. These implants would be less likely to be rejected by the body and could last longer, reducing the need for repeat surgeries. Furthermore, space-made glass could revolutionize the electronics industry. Its high transparency and conductivity make it suitable for use in next-generation displays, touchscreens, and solar panels. Imagine smartphones with unbreakable screens, or solar panels that are more efficient at converting sunlight into energy. These are just a few examples of how space-made glass could transform our technological landscape. The science of space glass is more than just a testament to human ingenuity. It's a beacon illuminating the boundless possibilities that lie at the intersection of exploration and innovation. As we venture further into the cosmos, we're not just unlocking the secrets of the universe, but also discovering new ways to improve life on Earth. The journey towards manufacturing materials in space is still in its early stages, but the discoveries made so far have been nothing short of remarkable. Space-made glass, with its exceptional properties and vast potential, stands as a powerful symbol of what we can achieve when we dare to reach for the stars. As we continue to push the boundaries of space exploration, we can look forward to a future where the materials that shape our world are no longer bound by the limitations of Earth. Space manufacturing holds the key to unlocking a future where technology knows no bounds, and where the possibilities are as limitless as the universe itself. It's a future worth striving for. A future where the stars are not just something we gaze at, but a source of inspiration and innovation that drives us forward.